Problem 5, chapter 17. Okay, we're going to compare using a binomial model and the normal model. So I'm sure you got part A right. Binom CDF 20, 0.275. And so the probability that you get 5 or fewer people that think that are pessimistic about marriage is around 0.536. All right, now let's use the normal model. But to use the normal model, we got to go through the preconditions. We can assume a Pew Research survey is random and independent. 20 is less than 10% of the population of American adults. NQ is 73 times 20, which is 14.6, but NP is only 5.4. A normal model should not be used since NP is less than 10, but they tell us to use the normal model, so we're going to go ahead and do it. So P hat is 0.25 because that's the percentage we're interested in, and P is 0.27. So the standard deviation of P hat is 0.27 times 0.73 divided by 20. So let's just go through this again on the calculator. So second, square root 0.73 times 0.27 divided by 20, close parenthesis. Okay, and so there's the standard deviation. So now you can see that the numerator for the z-score is going to be 0.25 minus 0.027, so that's going to be 0.02. So we're going to take our negative 0.02, negative 0.02 divided by the answer, which is the z-score, will give us, divided by the standard deviation, I should say, will give us the z-score, which is negative 2.015, which I have as a positive number here. That's negative. Sorry about that. Okay, so that's the z-score. Let me put a negative number in here as well. All right, and now we will calculate the probability that the z-score is 0.201 or less, and we'll do second and vars and normal CDF. And let's go back to the picture. So here's negative 0.201, and out here that's z equals. And out here at the end of the tail is z equals negative 99. So we'll do negatives. We're always going from left to right, so we'll do negative 99, comma, and then we'll use the answer again. Okay, so that probability is 0.42. All right, and okay. And so that's, now you can see that's quite different from the answer for B. The probability that you get 5 or fewer people are pessimistic about the future of marriage is 0.42, whereas with the binomial model, it was what, where is my answer here? 0.53, almost 0.54. So there's a big difference in the two answers. And the difference is due to the fact that the normal model shouldn't be used. It's the sample size is too small. Now the sample size for part 3C is 700. And so we do binom CDF again, and we get let's somebody go through that just for the sake of, just for the heck of it. So we'll do second and vars and binom CDF. NP, so put in 700, and P, in this case the population parameter, 0.27, comma. Now, we want to know what's the probability that we get 1/4 of the population, so you can just put in 1 divided by 4 times 700. You don't have to do another, like a side calculation, whatever the calculator will handle it for you. and we get 1, 2, 4, 7. Now let's save this because we're going to make a comparison between the answer for C and the answer for D. So I'm going to store this. Let me store this in memory location A. Okay, now let me clear this, and we'll go on and we'll use the normal model. Now we'll go back to our preconditions for D, and here's our okay, NP is 0.27 times 700, which is 189, and NQ is 0.73 times 700, which is 511. Since preconditions are met, the normal model may be used to describe the sampling distribution of p hat, 0.25. So the mu for p hat is 0.27. Standard deviation for p hat is 0.73 times 0.27 times 0.73 divided by 700. So let's start with that. Second, and so I'm going to do square root 0.27 times 0.73 divided by 700. And so there's my standard deviation, approximately 0.01678. Okay, now the z-score is again going to be negative 0.02 divided by that standard deviation. So I get negative 0.02 divided by the standard deviation, which I just calculated. Okay, so there's my z-score. Okay, and so let's go back to our drawing. So z equals negative 1.19, and then the end of the tail, the z is negative 99. So now I'm going to calculate the probability that the z-score is negative 1.19 or less. So I'll do second and vars, normal CDF, and I'll put in negative 99, comma, negative 1.19. Okay, and so there, that's the probability that 25% or less of the population is pessimistic about the future of marriage. Now these percentages, both of these percentages for the binomial and the using the normal model, are quite a bit smaller than the results that we got when the sample size was 20, and that's because there's less variation. The bigger the sample size, the less variation that we are going to have. Okay, so what is the difference between the binomial probability that 25% of the population or less is pessimistic about the future of marriage from the binomial model versus the normal model? So we're going to take, this is the result from the normal model. So I'm going to take the probability generated by the binomial model. So I'll do a second, I'll recall, all I have to do is alpha A minus, and I'll subtract the answer from it. And you can see the difference is quite small. Okay, we could round that to 0.008, or you could leave it 0.0077, whichever. Okay. All right. So the difference is when n equals 20, the A and B, the alpha, the A and B answers, the answers for part A and B are far apart because the normal model should not be used. For C and D, they are close since n is big enough. And the bigger the samples are, the closer that the two answers are going to be. But it's important to remember that the more correct answer is the binomial, and the normal model is an estimation because the data is discrete in binomial models, and with the normal model, it's assumed that the data is continuous. All right, so that's that.